According to the National Electrical Code, a single 20-amp circuit fit by 12/2 nm cable is sufficient for a single dedicated bathroom with the following items. Firstly, two 120 volts receptacles, also known as outlets. Secondly, an exhaust fan, typically 120 volts and 20 amps or less. And thirdly, general lighting, such as ceiling lights and vanity lights. The NEC has specific requirements for bathrooms. Firstly, at least one receptacle must be installed on each wall within 3 feet of the sink or bathtub. Secondly, a dedicated circuit is required if the fan is rated for more than 20 amps. Thirdly, lighting circuits are typically 15 or 20 amps. A single 20-amp circuit can generally handle typical bathroom lighting needs. Your 12/2 cable is designed to handle 20 amps at 120 volts, which is generally sufficient to power all of these components. It's important to ensure that the circuit is properly wired and protected by a circuit breaker or fuse size for the maximum load. A licensed electrician should perform the installation to ensure compliance with electrical codes and safety standards. Here is a more detailed explanation to help you further understand the process. Let's explore the essential electrical aspects of bathroom wiring, focusing on circuit requirements and safety standards. We will cover topics from receptacle placement to circuit breaker sizing, ensuring your bathroom electrical system is both functional and safe. Firstly, let's examine general circuit requirements. In a dedicated bathroom circuit, the National Electrical Code, or NEC, allows for a single 20-amp circuit to power multiple elements provided all NEC guidelines are met. This typically includes receptacles, lighting, and a ventilation fan. However, it is crucial to calculate the total load to ensure it does not exceed the circuit's capacity. Secondly, let's address receptacle requirements. The NEC mandates that at least one receptacle must be installed within 3 feet of each sink. This receptacle must be GFCI or ground fault circuit interrupter, protected to prevent electrical shocks in wet environments. For larger bathrooms, additional receptacles might be necessary to ensure no point along the wall line is more than 6 feet from a receptacle. Thirdly, let's discuss lighting considerations. Bathroom lighting typically includes a combination of overhead lights and vanity lights. Standard LED lighting fixtures consume relatively low wattage, usually between 10 and 30 watts each. However, if you have multiple fixtures or high-intensity lights, it is important to calculate the total wattage to ensure it remains within the circuit's capacity. Fourthly, let's examine exhaust fan requirements. Exhaust fans are essential for moisture control in bathrooms. Most residential exhaust fans draw between 1 and 2 amps. However, larger or more powerful fans might require more amperage. Ensure that the fan's amperage, along with the total load of other devices in the circuit, does not exceed the 20 amp limit. Fifthly, let's explore wiring with 12/2 nm cable. The 12/2 nm, or non-metallic, cable is commonly used for 20 amp circuits. This cable consists of 2 insulated wires, one hot and one neutral, along with a bare ground wire. It is rated to handle up to 20 amps at 120 volts. Ensure that the cable is properly secured and protected according to NEC guidelines. Sixthly, let's discuss circuit breaker protection. The 20 amp circuit must be protected by a 20 amp circuit breaker in the electrical panel. The circuit breaker is designed to trip or cut off power if the circuit is overloaded, preventing overheating and potential fires. Regularly inspect the circuit breaker to ensure it is functioning correctly. Seventhly, let's discuss GFCI protection. GFCI protection is crucial in bathrooms due to the presence of water. GFCI receptacles or circuit breakers detect ground faults and quickly cut off power, reducing the risk of electric shock. The NEC requires GFCI protection for all receptacles in bathrooms. Eighthly, let's address the calculation of total load. To determine if a 20 amp circuit is sufficient, calculate the total load by adding up the wattage of all devices that will be connected to the circuit. Convert wattage to amperage by dividing the wattage by the voltage, which is typically 120 volts in residential settings. The total amperage should not exceed 80% of the circuit breaker's rating, which is 16 amps for a 20 amp circuit. Ninthly, let's consider dedicated circuits. While a single 20 amp circuit can suffice for a small bathroom, consider installing dedicated circuits for high demand appliances like hairdryers or electric heaters. This prevents overloading the general bathroom circuit and ensures consistent power supply. Lastly, let's emphasize the importance of professional installation. Electrical work should always be performed by a licensed electrician. A professional ensures that all wiring meets code requirements, is safely installed, and is properly grounded. Improper wiring can lead to serious safety hazards, including electrical shocks and fires. Now let's get into some more detailed concepts and guidelines. We will discuss each component with specific numbers and voltage examples for you to understand. Firstly, regarding receptacle placement and spacing, NEC specifies that at least one receptacle must be installed on each wall space that is 2 feet or wider. Receptacles should be positioned within 3 feet horizontally from the edge of the sink. This ensures easy access to power outlets without stretching cords across wet areas. For example, if a bathroom has a vanity that is 4 feet wide, a receptacle must be installed within 3 feet of the sink. This receptacle must be GFCI protected. Secondly, let's look at GFCI protection requirements. All 120 volt, 15 amp and 20 amp receptacles in bathrooms must have GFCI protection. GFCI devices are designed to detect ground faults, which occur where electricity flows along an unintended path, like through a person. When a ground fault is detected, the GFCI trips the circuit, cutting off the power in milliseconds to prevent electric shock. GFCI protection can be provided either by using GFCI receptacles or a GFCI circuit breaker. For example, if a hairdryer falls into the sink, the GFCI will detect the ground fault and immediately cut off the power. Thirdly, let's consider lighting circuit considerations. Bathroom lighting typically includes overhead lights, vanity lights, and shower lights. These lights can be powered by the same 20 amp circuit that serves the receptacles, provided that the total load does not exceed the circuit's capacity. Standard LED bathroom lights typically consume between 10 and 30 watts each. If you have multiple fixtures, it's important to calculate the total wattage. For example, if you have 6 15-watt LED lights, the total wattage is 90 watts. The amperage draw is calculated by dividing the wattage by the voltage, which is 120 volts. 90 watts divided by 120 volts equals 0.75 amps. This is well within the capacity of a 20 amp circuit. Fourthly, let's look at exhaust fan specifications. Bathroom exhaust fans are crucial for removing moisture and preventing mold growth. Most residential exhaust fans draw between 1 and 2 amps. The NEC requires that exhaust fans be installed in bathrooms to ensure adequate ventilation. Check the fan specifications for its amperage draw. For example, if an exhaust fan draws 1.5 amps, this should be factored into the total load calculation for the circuit. Fifthly, let's consider dedicated circuits for high-demand appliances. While a 20 amp circuit can handle typical bathroom loads, it's wise to consider dedicated circuits for high-demand appliances. Hair dryers and electric heaters can draw significant amounts of power, potentially overloading the general bathroom circuit. A typical hair dryer can draw between 10 and 15 amps. If you frequently use high-powered appliances, a dedicated 20 amp circuit can prevent nuisance tripping of the main bathroom circuit breaker. Sixthly, let's discuss wiring with 12/2 and 12/3 nm cable. The 12/2 nm cable consists of 2 insulated conductors, one hot and one neutral, plus a background wire. It is commonly used for 20 amp circuits. The 12/3 nm cable includes an additional insulated conductor, typically used as a second hot wire for split-wired receptacles or switches. Ensure that the cable is properly secured with cable staples every 4.5 feet and within 12 inches of electrical boxes. For example, when running 12/2 cable to a bathroom receptacle, ensure it is securely fastened to the studs to prevent damage. Seventhly, let's address circuit breaker sizing and load calculations. The 20 amp circuit must be protected by a 20 amp circuit breaker. The maximum continuous load on a circuit breaker should not exceed 80% of its rating. This means that for a 20 amp circuit, the maximum continuous load should be 16 amps. To calculate the total load, add up the amperage of all devices that will be connected to the circuit. For example, if you have lighting totaling 0.75 amps, an exhaust fan drawing 1.5 amps, and receptacles expected to handle a maximum of 10 amps, the total load is 12.25 amps. This is within the 16 amp limit. Eighthly, let's consider voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause appliances to malfunction and lights to dim. The NEC recommends limiting voltage drop to no more than 3% for branch circuits. Use a voltage drop calculator to ensure that the wire gauge is adequate for the circuit length and load. For example, for a 75-foot run of 12-gauge wire carrying 16 amps, the voltage drop should be within acceptable limits. Ninthly, let's discuss electrical box fill. The NEC specifies the maximum number of conductors that can be installed in an electrical box. Overfilling electrical boxes can cause overheating and increase the risk of electrical hazards. Each conductor, device, and fitting inside the box counts towards the fill capacity. Use the NEC box fill calculations to ensure that the electrical boxes are not overfilled. For example, a standard 3-inch by 2-inch by 2.5-inch electrical box can typically accommodate 6 12-gauge conductors. Lastly, let's reiterate the importance of professional inspection. Electrical work should always be inspected by a qualified electrician or electrical inspector. A professional can ensure that all wiring meets code requirements, is safely installed, and is properly grounded. An inspection can identify potential hazards and ensure the long-term safety and reliability of the electrical system. For example, after completing the bathroom wiring, schedule an inspection to ensure that all connections are secure, GFCI protection is functioning correctly, and the wiring is properly grounded. Now let's examine the requirements for installing electrical components in a bathroom, including specifics on receptacle placement, GFCI protection, lighting, and wiring. We'll also look at the code requirements that dictate safe and effective installations. Firstly, let's address receptacle placement requirements. The National Electrical Code, in section 210.52, T specifies that at least one receptacle outlet must be installed within 3 feet of each sink in a bathroom. This requirement ensures that users can easily access power for appliances like hair dryers and electric shavers without running extension cords across wet areas. If the basin is installed in a countertop, the receptacle must be no more than 12 inches below the top of the countertop. For example, if you have a vanity with 2 sinks spaced 5 feet apart, you need to install a receptacle within 3 feet of each sink. These receptacles must be readily accessible and not obstructed by permanent fixtures. Secondly, let's examine GFCI protection. Section 210.8 of the NEC mandates GFCI protection for all 120 volt, 15 amp and 20 amp receptacles installed in bathrooms. GFCI protection is designed to protect against electric shock by detecting ground faults and quickly cutting off the power. A ground fault occurs when electricity strays from its intended path and flows through a person, creating a dangerous shock hazard. GFCI protection can be achieved using GFCI receptacles or GFCI circuit breakers. For example, if a hairdryer falls into a sink filled with water, the GFCI will detect the ground fault and trip the circuit, preventing a potentially fatal electric shock. Regular testing of GFCI devices is recommended to ensure they are functioning correctly. The test button on the GFCI receptacle should be pressed monthly to verify that it trips and cuts off power. Thirdly, let's look at lighting circuit requirements. Bathroom lighting typically includes overhead lights, vanity lights, and shower or tub enclosure lights. The NEC permits these lights to be powered by the same 20 amp circuit that serves the receptacles, provided the total load does not exceed the circuit's capacity. Lighting fixtures installed in damp or wet locations, such as showers or tub enclosures, must be rated for those environments. These fixtures are designed to prevent water from entering and causing electrical hazards. For example, if you install recessed lighting in a shower, the fixtures must be listed as suitable for wet locations and be IC rated if they are in contact with insulation. Fourthly, let's consider wiring methods and cable types. The most common wiring method for bathroom circuits is non-metallic sheath cable or NM cable, such as 12/2 NMB for a 20 amp circuit. NM cable consists of insulated conductors enclosed in a non-metallic jacket. The NEC specifies requirements for how NM cable must be installed and supported. NM cable must be protected from physical damage and securely fastened to studs or joists using cable staples or straps. The cable must be supported within 12 inches of an electrical box and at intervals not exceeding 4.5 feet. For example, when running 12/2 NMB cable through the wall to a receptacle, ensure it is properly stapled to the studs to prevent it from being pulled or damaged. Fifthly, let's address electrical box fill. The NEC sets limits on the number of conductors, devices, and fittings that can be installed in an electrical box. Overfilling electrical boxes can lead to overheating, damaged insulation, and potential fire hazards. The box fill calculation is based on the volume of the box and the size and number of conductors and devices inside. Each conductor entering the box counts towards the fill calculation, as do device yokes, internal cable clamps, and equipment grounding conductors. For example, a standard 3" by 2" by 2.5" electrical box has a volume of 12.5 cubic inches. If you have 6 12-gauge conductors, 1 device yoke, and 1 equipment grounding conductor in the box, you need to ensure that the total fill does not exceed 12.5 cubic inches. Sixthly, let's consider arc fault circuit interrupter or SI protection. The NEC requires SI protection for branch circuits that supply 120 volt, 15 amp and 20 amp outlets installed in dwelling units. SI protection is designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults occur when electricity jumps between conductors or to ground, creating a spark that can ignite nearby materials. SIs are more sensitive than standard circuit breakers and can detect arc faults before they cause a fire. While not specifically required for bathroom receptacles, SI protection is often recommended for the entire branch circuit that serves the bathroom to enhance safety. Seventhly, let's consider ventilation and exhaust fans. Bathrooms generate a lot of moisture, which can lead to mold and mildew growth. The NEC requires that bathrooms have adequate ventilation to remove moisture and prevent these problems. Ventilation can be provided by a window that can be opened or by an exhaust fan. Exhaust fans must be sized appropriately for the size of the bathroom. The Home Ventilating Institute, or HVI, recommends that exhaust fans provide at least 50 cubic feet per minute, or CFM, of airflow for bathrooms up to 50 square feet. Larger bathrooms require more airflow. For example, a 75 square foot bathroom should have an exhaust fan that provides at least 75 CFM of airflow. Eighthly, let's discuss lighting fixture clearances. When installing lighting fixtures in bathrooms, it's important to maintain adequate clearances from bathtubs, showers, and other water sources. The NEC specifies minimum distances that lighting fixtures must be located from these areas to prevent electric shock hazard. Lighting fixtures installed within a certain distance of a bathtub or shower must be GFCI protected and rated for wet locations. For example, a recessed light installed in a shower ceiling must be listed for wet locations and be installed at least 8 feet above the top of the bathtub rim or shower threshold, unless it is GFCI protected. Ninthly, let's emphasize bonding and grounding. Proper bonding and grounding are essential for electrical safety. Bonding ensures that all metal parts of the electrical system are connected together to provide a low impedance path for fault current. Grounding provides a path for fault current to return to the source, tripping the circuit breaker or GFCI and preventing electric shock. The NEC requires that all metal enclosures, such as electrical boxes and lighting fixtures, be bonded and grounded. For example, When installing a metal electrical box in a bathroom, ensure that it is properly grounded by connecting it to the equipment grounding conductor in the circuit. Lastly, remember the importance of professional review. The electrical work in bathrooms can be complex and requires careful attention to detail to ensure safety and compliance with the NEC. It's always recommended to hire a qualified electrician to perform electrical work in bathrooms. A licensed electrician has the knowledge and experience to properly install wiring, receptacles, lighting, and other electrical components in accordance with code requirements. A professional electrician can also inspect existing electrical systems to identify potential hazards and make recommendations for improvements. For example, before starting any electrical work in your bathroom, consult with a licensed electrician to discuss your plans and ensure that the work will be done safely and correctly.